Hello and welcome to the webinar, How the Leather Industry Can Use Science and Data to Improve its Image, brought to you by ILM in association with raw materials pricing website, The Sauer Report. I'm Isabella Griffiths, the editor of International Leather Maker, the leading leather industry business information brand. I would like to acknowledge our webinar sponsor, JBS Kuros. The company's sustainability manager, Kim Senna, is among today's presenters. This webinar will explore how the leather industry can use science and data and how this can be used as a tool to turn around the negative narrative surrounding the material leather. Before we start with our first presentation, I would like to give a brief introduction to International Leather Maker and a brief overview of what the Sauer Report covers. ILM serves the global leather supply chain across several media platforms, online and through a number of other digital formats, as well as 6 printed magazines. The website, internationalleathermaker.com, is updated several times daily with the latest industry news, views, and information. Please keep an eye out for further upcoming webinars and other digital events which will be announced on our website. We also broadcast a series of industry-specific, free-to-download podcasts which form part of our View from the Top series. You can access all the podcasts by visiting our homepage. The Sauer Report was founded in 1985 and is an online raw materials pricing, analysis and trends website, which is updated daily from a network of sources from around the world and is available for paid subscribers. It provides valuable market information such as hide and skin prices and is a useful tool for traders, tanners, brands and retailers, OEMs, as well as associated suppliers. So now I will introduce today's presenters. The first presentation will be by Dr. Michael Meyer, Scientific Director and Managing Director at Filk Technical Institute in Freiberg, Germany, and Dr. Sascha Dietrich, Director of the Testing Laboratory at Filk, who will give an overview of the recent study, Leather versus Alternative and Trendy Materials. The second presentation by Kim Senna, Sustainability Manager at JBS Kuros, will cover key lessons from the recent lifecycle analysis of the company's Kind Leather and demonstrate how leather can have a low or positive LCA score compared with other materials. Finally, Johan Rejean, Biodiversity and Animal Welfare Specialist at global luxury conglomerate Kering, will talk about the group's environmental profit and loss account and best practice. The presentations will be followed by a brief Q&A session. So now for our first presenters, Dr. Meyer and Dr. Dietrich from Filk.
Thank you, Isabella, for this kind introduction. My name is Michael Meyer. I'm the Scientific Director of Filk Freiberg Institute. And I'm working here for a long time, I think. And to my left is Sascha Dietrich. He's the head of our testing lab. Sascha, you are working a long time at Filk as well?
Yes, I do so. I'm here for more than 9 years now. As Michael said, I'm the head of the accredited test laboratory. So this means I'm responsible for testing matters. Me and my colleagues, we perform quite a lot of different standardized test methods. For instance, physical testings, chemical analysis, but also emission testings. And beside that, we also perform special testings, and we do have failure analysis in our portfolio. So in Filk Institute, the colleagues do have a deep expertise and also a profound technological competence in materials like leather, of course, but also coated textiles, textiles itself, and plastic materials, means plastic films, plastic parts, and composites thereof. So in addition, we also do testing on chemicals and on medical products.
So this is as well the connection to our title of the webinar we will show you today. We presented a study where we compared leather, artificial leather, I would say coated textiles, and also these so-called trendy substitutes. We were a long time thinking about this wording here. And we try to compare them regarding a couple of different parameters. And today we would like to show you some of these principles of the material composition on one hand, on the second hand, some of these results. So let us begin with the reference material, leather. We can see that we have a principled structure here with coarse collagen fibers at the bottom, in the middle, a more dense layer of collagen fibers, and a small, a very thin top layer as well on collagen fibers, and to some time also a top coat made from synthetic polymers. But the principal structure of leather, the cross section, is composed of collagen, a hydrophilic protein fiber made from skin or reflecting the skin structure.
So another material we are dealing with here in HiGG Institute is, of course, artificial leather. Here on the screen, you can see a scheme of an artificial leather structure. So at a first glance, it looks completely different to that what we have seen presented for leather from Michael just a few moments ago. But you have to keep in mind that the aim of this artificial leather structure is to imitate leather peculiarities, leather properties. And for that reason, let's have a closer look on the structure. You can see that the artificial leather structure is also a layered structure. We do have a textile support, which is coated by two polymer layers. The first one is a foamed polymer layer, and the second one is a dense polymer layer. And on the top of the artificial leather, we do have a top coating. So most of the polymers used for artificial leather applications originates from fossil-based raw materials. And quite often, artificial leathers are made from PVC or polyurethane materials. But very recently, also HiGG Institute came up with some new developments, with some new silicon-based coated textiles, and in addition with some systems based on biodegradable polymers.
So this leads us to the next question, Sasha. The trendy substitutes which are on the market are partly based on really grown other materials, vegan alternatives. And one example is shown here. We can see that we have a material which is based on fungi. So the hyphae, the thin fibers which are made from or which grow from the fungi, then reflects the basic structure of this material. And we can see that we don't have a layered structure in this case. We have just a homogeneous material, which is, I would say, open and homogeneous over the complete cross section, I would say. So that these are not only schemes, we can now show you as well the cross sections which are prepared by microscopy. And here we can see that we really reflect these materials in the microscopic cross sections of these materials by these schemes. We have the layered structure of leather, we have the layered structure of artificial leather or coated textile, and finally the fungi material, which is based on the hyphae of these fungi. And if we now look on further materials, Sasha, these had not been the only materials which we tested.
No, indeed not. We had a look quite on a variety of different materials, different trendy substitutes. All of the materials you can see on this screen here are supposed to be potential alternatives to leather. So we looked for the intrinsic structure of these materials and also on the technological performance. And the results obtained were compared to two reference materials. First, we use a shoe upper leather as a reference, and as a second, we used a polyurethane coated textile, an artificial leather, as a reference. And as all these materials are more or less similar in their final applications with respect to shoes, gloves, and apparel goods, we referred to the corresponding international specification and standards for testing. And among others, we tested the mechanical properties in a tear strength test and in a tensile strength test, and we also tested the physical properties in a water vapor permeability test, for instance.
And regarding the mechanical tests, how does it work?
Well, the mechanical test is, of course, the most important test for materials applicated in shoes, gloves, or apparel goods. And that's why I want to give some further explanation on that now. Well, using an automatic operating tensile testing machine, the well-defined specimen is clamped and then extended by a certain rate until the specimen breaks. And based on the recorded force elongation plots, you can extract quite a lot of different information. You can get the information about the maximum force. You can get the information about the elongation at maximum force, and you can get an information about, of course, the tensile strength or the tear strength.
and this is the mechanical tests, I think. Do we have other parameters which are very important for these materials?
Of course, there are also other parameters that are very important for the materials, like the water vapor permeability. But let's have a closer look on the results we obtained here. So interestingly, the results for the individual tensile strength values from the different materials vary in a wide range. So looking for leather showed the highest values for both the tensile strength and also for the tear strength. Artificial leather-based materials showed even lower values, some of them even not achieving the requirements given in the specification. And remarkably, the tensile strength and the tear strength for the fungi-based material muskin was the lowest in our comparison, even 2 orders of magnitude lower than, for instance, leather.
So let's have a look on the reason why this happens. And if we compare these different materials regarding these mechanical results, we can see and reflect again on the structure. We can see in the case of leather, we have these fibers which orient in the direction of the load. We have the artificial leather or coated textile, where the support mainly determines the mechanical properties. And in the case of the fungi material, we have only the hyphae, which are oriented in perpendicular to the surface, and they are just pulled one beside the other, and as a result, this has the lowest properties. And if we simulate this, this is looking like this. The leather behaves very strong. The artificial leather is mechanically stable, but depending on the support, and the fungi material is destroyed very fast.
Yes, these were the explanations for the tear test and also for the tensile test, for the mechanical properties. So, but what about the physical properties? As you already mentioned, the water vapor permeability, for instance.
This is a completely different topic, of course, because in this case we have a physical property. It's not the mechanical stability. And again, to reflect on the schemes we have shown here, we have tightness of the material. And as we expect, the mushrooms or the fungi material is a very open structure. So the water vapor permeability should be very high. In case of the coated textile, it should be very low because we have a tight synthetic polymer film on top. And in between, we find the leather as expected, because the leather is hydrophilic on one hand, but it has a tight structure. Let's have a look on the bubbles on the bottom. These are reflecting the water molecules, and they're diffusing very fast through the middle picture to the leather. They are retarded in the dense layer on top. And in case of the artificial leather or the coated textile, the diffusion stops in the polymer foam in the middle of the material.
So as Michael already mentioned, water vapor permeability is quite a welfare comfort property in terms of shoes, gloves, and apparel goods applications. And that's why we did the test on these materials as well. So we used a cup similar like this one. We filled it with a desiccant, which is a hygroscopic substance. We covered it by the material to be tested, and afterwards we brought the whole sample into a defined climate condition. So the water vapor permeability is determined by measuring the increase in weight over a period of time. And quite interesting, we could find huge differences in the performance of the materials. So for the natural materials like leather and also the fungi-based muskin material, we could observe the highest values for water vapor permeability. And this is very much in line with the explanation given by Michael, depending on the structure of these materials. In contrast, materials based on the artificial leather structure with a considerable amount of synthetic polymers components inside the structure, they showed a quite low or even no water vapor permeability properties. So, and this is a quite interesting finding, and this leads to some further questions.
So the question is, what will happen with the other materials you have shown in the microscopic pictures, these cross sections with completely different structures. And we have these three principles. Could you show the values for the other materials?
Of course I can. We performed all the tests on all materials, and I would like to point your attention to these graphs here. You can see the individual performances of the materials for the tests we run on these materials. So you can see that there are single values of properties from the individual materials that are very close to leather, but none of these trendy materials can achieve all the values, all the properties as leather can. So as a summary, as a finding of our study, we can say that leather is showing the most universal properties in this comparison.
And if you now look again for an explanation for this, we can reflect again on the structure of the leather, and we see that we have a gradient in the density. We have a main fiber direction, which determines the tension or the mechanical properties of the material. The density determines the water vapor permeability and a couple of other properties of the leather. So the reason for this universal property is this gradient structure and these structure of these different fibers in the different layers. And let me say some last words about why we could find this or how we can explain this. The leather is a copy of the skin, of the animal skin, and the animal skin has a biological function. This function is on one hand to protect a body against mechanical damage, and a second explanation or a second important property is that the skin has to regulate temperature and humidity of a body. So these both properties will be retrieved in case of the leather, and this is, I think, one possible explanation for this universal property and universal function of leather.
Okay, so these were the findings, the results we wanted to share with you for today. You can be sure that we are going on in investigation on further trendy substitutes, and there will be a follow-up on our findings, on our results obtained on further materials very soon. At the moment, we would like to thank you for your kind attention, and we would not close this webinar without giving some more information, some more impressions about our HiGG Institute. Therefore, you can find a very short movie right after our presentation. So thank you very much. Goodbye and auf Wiedersehen.
Brilliant. Thank you so much to both of you for this overview of this much anticipated study. And you highlighted some really interesting findings there. And it is great that there is finally some scientific evidence on this subject as well. So yeah, thank you so much for that. And now I'll hand over to our second presenter, Kim Senna.
So thank you, Isabella. Thanks everyone who's watching. It's a pleasure to be here. This topic specifically, I think it's very hot and it has everything to do with our challenges nowadays. So let's start. Well, first of all, I'd like to share a bit of the concept of life cycle perspective, right? So whenever you're assessing the environmental impact of a material, also the social impact of a material, but when you're assessing its impact as a whole, you actually have to look at the whole value chain, right? Because if not, I mean, you could be disregarding something really important. Let's say, for instance, if we're talking about a cotton shirt, we have to take into account the agricultural part of the value chain. The same for polyester. For instance, you have to consider shale gas extraction or oil extraction. And of course, the same applies to leather. But after that, also the use phase of the material, the transporting, and also how you deal with the product in the end of its lifetime, it's also very important because it will make a difference, right? So this is one first point, and we actually engaged with that last year for the first time with a life cycle assessment, an LCA. And well, it is a very broad thing, right? To assess the whole supply chain. But then the first decision you actually make is the system boundary, right? So when your assessment starts, where does it start and where does it end? Because you can't assess the whole thing. So our LCA did consider the process from cradle, so from farm to gate, which is the finished leather. So in everything in between. So and then I share here Tannery 1, 2, and 3 because we actually produced this specific article in 3 different tanneries. The point is, one important point about LCA is that it's very product specific. So you can't apply the same results for every, in our case, leather we produce, because every leather has a very specific recipe, a very specific process. So that's one important thing to bear in mind. It's that it's very product specific and it's very data intensive. I mean, among the 3 stakeholders in this LCA, which were us, JBS Corals, Asia10, which is a partner, Tannery, and Spin360, which is the consultant company which carried on this study itself. We did gather more than 10,000 data among 220 variables. So it's very intensive in that sense. And also, I mean, but it's also very enlightening in the end. So we are actually engaging in several other LCAs to properly understand our processes and the environmental impact of our activities. One very hot topic last year was also the HiGG Index and how it compared materials and how the natural fibers were seen within the tool. What the HiGG Index actually does is collect LCAs, evaluate them, and then make them available in an online hub where decision makers can actually use those results to compare materials and make decisions. So sourcing decisions or design decisions, specifically looking at the environmental impact of materials. And in the past, they used to have what they called a single score, which was a very easy way to communicate, and everyone loved that for this reason. But the problem is, to do that, you actually have to weigh impacts and judge impacts and normalize impacts. And the problem is, you add uncertainties to the final result, to the final number. So what they did recently was to decide to abolish the single score, and now they have the 5 impact categories, and they express the results in 5 different impact categories. So there's no judgment of what is more important, fossil fuel depletion or global warming potential. They just express different results. Then they compare the materials. So the problem then in the discussion was, of course, we are not happy at the way leather is expressed there, and it's not only not being happy, we don't think it's fair. We don't think it's properly expressed. What we did with our LCA then was upload it to the platform, and it did bring us to a better position. And this is a plot for global warming potential, but we did learn a lot of things and what we were doing properly, where we have to improve. And the idea here would be to share a bit of our learnings. One important thing also to bear in mind is that leather shines in a few of the impact categories. So for instance, resource depletion. Leather is not a carbon intensive material. So it's actually the second best in terms of resource depletion, way ahead of the synthetics, for instance. But then we'd like to split here the learnings in two main pillars, one of them being data accuracy, the other the efficient use of resources. So starting here with the first one. So there are actually two types of LCAs, two standard types. There's the attributional, which is definitely the most used, and it's the one we used. And there's also the consequential, but it's something that it's not so common in the industry so far. So getting to the attributional one, what it does is to calculate what fraction of the global environmental burden belongs to a specific supply chain or a process. And to do so, it uses allocation factors and for weighting, right? So in the case of, as I was mentioning, of cotton, it's really important that we consider the impact of agriculture to cotton and to a cotton shirt. And in the case of leather, the same thing. So you have to consider somehow what is how much of the impact from the bovine should be allocated to leather, and it does so by considering two variables: the mass fraction of how much the hide represents of the animal, and the economic value. It does that in a very simple way. So you have to actually get that primary data, and it's something really particular of the study we did, because we were actually able to get the primary data of how much the hide represented of the both variables. But it's not always like that. If you don't have, you have to use a standard table, and that's usually not the best approach because it's less precise. And also, same for water, for energy, you have to have primary data for proper calculation of how much you use. In chemicals, same thing, but with chemicals, things get a bit more complex, because then you have, of course, a lot of chemicals, and you have to assess all of them. So about the allocation, as I was mentioning, so this is a plot for global warming potential. And as we can see, roughly 50% of the total impact of the finished leather is actually coming from the farming practices. So it's a lot. I mean, if we look at finishing, only 9%. So if everything we do to improve and to decrease our environmental impact in the finishing part regarding global warming potential, I mean, it's minimal compared to if we act on farming. So and the problem is there are very few LCA models for farming, so they are they simplify too much, and they actually don't take into consideration the different variables such as the feed, the climate, for instance, or even the type of animal. So these variables actually make a lot of difference, and what the industry should evolve to actually get better allocation results to leather is to push the calculation and the modeling of other LCAs to get better results, and to get more precise results actually, and be able to be more fair. Talking about chemistry, and this is where leather doesn't have a very good image so far. So it is, as you can see, leather is seen here in the brown and green bars, light green bars, as the worst material so far within the HiGG Index. And so we're sure there's a lot of room to improve here. But again, a lot of it has to do with how we calculate, and not with the reality itself. So let's say this is a plot of what we did from our LCA, and we started analyzing where we can improve, and where what chemicals are more or less impactful. And the thing is that we see that since we don't have LCAs for, well, we actually have for very few of the chemicals, the problem is you have to use approximations, and when you approximate, you have to be conservative, and then you actually get a higher result than what the reality actually is. So one thing we have to improve is, well, getting more LCAs for our chemicals. And I mean, it might seem expensive, but it's actually not. When we have a lot of chemicals in a given factory, for instance, it's not really expensive, but also the utilization, right? To make sure whatever chemical you're using, you are actually using it, and it's not going all the way through your process and ending up in the treatment plant, and you have to pay twice, right? To buy the chemical and to treat it. So these two approaches are the ways, at least we are dealing with it to improve in the chemical impact category and actually get a better result in the near future. And then talking about the efficient use of resources. And here I borrowed a concept from a book, a very famous book actually, which tries to bring this cradle to cradle approach where everything is circular and you use your materials over and over and not in a linear way. The book shares this analogy with the cherry tree. And well, the cherry tree, as we all know, it's very beautiful, and when it blossoms, it's a wonder of nature. And before it provides fruits for insects or humans or other wildlife, it actually produces all these blossoms. And when anyone looks at it, I suppose no one thinks that it is not efficient or that it's wasteful, and because it's not. The thing is, the cherry tree, when it produces all those blossoms, it actually decomposes on the floor and it becomes food for ants and nutrients for the soil, and eventually these nutrients actually come back to the tree and well, and it's used again, so nothing is wasted. And this is a concept that applies to every industrial ecological system that wants to get better. It's that making sure your waste is well, being used somewhere. And leather does that, right? Because leather is about using a byproduct of the animal protein industry and making a beautiful material out of it. So by essence, it is already communicating with this concept. The thing is, we of course have ways to improve. So in the material flow for leather, you actually have trimmings, right? And whatever you're trimming there actually becomes collagen, and it's mostly collagen and fat, right? And the collagen is used in other material systems, in other industries. And when you do that, you allocate those small pieces of the impact that you've been calculating to these other systems. The problem is, since it's so little, it's not a lot that you trim, almost all the impact from cattle raising, although that 50% actually is brought to leather and to the end product, a shoe, for instance. And the thing is, if we want to improve that, most of the times design solutions are simple solutions and elegant usually, and a good way to approach it, right? So and this is the way we approach it in kind leather. So we trim those parts of the hides that are richer in natural defects, so the bellies and the neck area. And when we do that, in terms of LCA here, when we do that, we are actually allocating those trimmings, those large trimmings, to other industries. So since they become raw materials to these other industries, that impact from cattle raising and from the process up to the beam house, it doesn't come to the leather. So it actually goes somewhere else. So it will be an impact for the cosmetic industry or the pharmaceutical industry. And this is a very important point to understand how approaching leather production from the kind leather point of view actually is very beneficial for the results, because a lot less of the farming impact is actually allocated to leather itself. And then you produce less waste, and then again, you are working towards a more efficient industrial system. Another concept here that's important to share, and it's some considered the most important concept and the first concept to be thought of while thinking of a life cycle assessment, is the functional unit. by definition, it is the quantified description of the performance requirements that the product system fulfills, but trying to explain that more easily in an example here. So let's say for wall paints, if we want to compare one given brand with the other through an LCA, the question to build the functional unit should be broader, right? So it should address how much of it I'm using, where I'm using, how well the paint performs. And those are very important because if I compare one paint that's gonna last for 5 years with the other that's gonna last for 10 years, and they both have the same impact, well, the one that's lasting for 10 years should get a better result, right? Because you won't have to paint it again. And this is really important for leather because a proper functional unit should capture all that, should capture the durability and the repairability variables of leather. But when we look at it nowadays, since we are thinking of it from a cradle to gate approach, it only calculates the impact per square meter or per kilogram of the material. So it's disregarding how long it's going to last, for instance, and that's definitely not well precise as an assessment. And this won't change because I mean, when people calculate LCAs for materials, they actually look at it from a cradle to gate perspective, and that will be so for the time being. But the thing is, we from our side can engage in technical calculations and assessments to do it anyway, right? Because it's within the life cycle perspective. Again, I'm sharing here the slide again. If you only consider the first light green parts of the production process, which is what the current HiGG Index or current cradle to gate approach measures, you are disregarding the rest, and that's not precise at all. And when we think of the manufacturing part of it, we also have to think of how much of the resources I'm using or of the materials I'm using actually end up in a shoe, for instance. Because here, and it's about the material utilization of kind leather, when we see a regular leather, you do see that the shape while you're nesting, and this is an automotive kit, while you're nesting, you actually have inefficiencies regarding the shape of the material because it's a natural material, and that's how it comes, right? But you did produce it all the way through, and in the end you're left with these trimmings that, well, are waste in the end, and you have to deal with it. When you optimize the shape in the beginning, what you end up with is a more regular shape, and you have less waste in a higher cutting yield. And in the end, again, you're needing less of that material that you produce all the way through to make the same amount of shoes. And this also should impact, right? Because when we see the whole life cycle and we consider the HiGG Index, you're calculating it from farm to tannery, so you don't consider the cutting yield. But the HiGG Index also has this other tool, which is called the HiGG PM, the HiGG product module, where it does consider the cutting yield. And for a designer who's producing a shirt, for instance, or a shoe, it can actually calculate, use this as an input, right? What's the cutting yield, so that he can calculate the proper impact of the material. Also, other things that are disregarded are the use phase, again, and the repairability of materials and recyclability, or what can you do for upcycling. And we all know that leather also has a very good way to approach these downstream parts of the value chain, and being able to calculate that better and to communicate that better, and when comparing to other materials, should help us a lot. And just to summarize everything here, I mean, science can help as a framework for improvement. So the LCA is a first step, but then you can use it, of course, to communicate. But the thing is, you communicate once and that's it. But if you use that as an input for improvement, and so if you do a hotspot analysis, so you evaluate what are the worst chemicals in your process and how can you decrease them or replace them, or if you understand what machines are consuming more energy, and then you do a what if analysis and test, and what if I replace this machine with another one, or this chemical with another one, you then will achieve improvements, and when you run an LCA again, you actually get a better result, and that's a positive approach, and science is helping you here, right? And well, just to wrap up, I strongly believe that leather and lobby aside and communication aside, leather has a very strong story, sustainability story, and science can be and should be an ally, and it should help us to communicate it a lot better with better numbers and with a more precise picture of what leather really is. So thank you very much.
Thank you very much, Kim. That was great and very insightful. Thank you. And now I'll hand over to our final presenter, Johan Rejean.
Good morning, good afternoon, everyone. I'm really happy to be the guest of this webinar today to speak to you how Kering is addressing the topic of sustainable leather in its sourcing and how Kering is using science to actually demonstrate that leather can be a sustainable material. My name is Johan Rejean, and I work as a sustainable sourcing, animal welfare, and biodiversity specialist at Kering. And I will take you along the sustainable leather journey for the next 15 minutes. So as a reminder, Kering is a global luxury group that develops an ensemble of luxury houses in leather, fashion, jewelry goods, and watches. As laid out by our CEO, François-Henri Pinault, the vision of Kering is that sustainability is not just an imperative, but a business opportunity, and basically the only option to tackle the major challenge of this century. And as such, as a luxury group, we have a duty to lead by example and to act and to show the path. So I will just have a brief introduction of what is actually our sustainability strategy before digging into the topic specifically of sustainable leather. So our sustainability ambition at Kering is really to craft tomorrow's luxury with 3 dedicated pillars that we want to achieve by 2025. They are, first of all, the caring, which is quite appropriate as a name for our company. The caring pillar, which is pretty much about addressing our impact on nature, on climate change, and on the planet as a whole. Then the second pillar, is on collaboration, which is how we collaborate internally with our employees, but also externally with suppliers and with clients in order to achieve our sustainability vision. And then finally on creating, which is more on how do we foster innovation in line with our heritage to achieve this sustainability vision that we have. And now running into where we are at when it comes to our sustainability ambitions and some key figures. So the first key figure I want to introduce is actually the reduction of our group overall environmental footprint as measured by the environmental profit and loss, a tool that I will present just after. So we have actually reached a 29% reduction between 2015 and 2019, which shows that we are really on track to reach our 40% reduction objective by 2025. Additionally, we are now capable to trace 91% of our raw materials to their source origin. So for instance, for leather, it means that we are able to trace back the raw materials all the way up to the slaughterhouse. And we have as an ambition to reach 100% by 2025. And finally, a last figure that I want to highlight is the fact that we have been able to gather more than 3,800 sustainable materials in our material innovation lab in Milan. And that means that thanks to this library that we are building, we've actually been able to switch more than 800 conventional raw materials to sustainable alternatives. Something that is not highlighted there, but it's very important, is actually how we achieve these numbers and these figures and these milestones. The first one is the importance of working within your supply chain and actually tracing the flow of your materials all the way to their origins, because as we will see later on, most of our impact actually happens at what we call tier 4, which would be for leather, the farms where the animals is raised. So it's very important to have traceability. a way to achieve this traceability, and that brings me to my second point, is through collaboration. So collaboration across the fast fashion industry, such as what Kering is leading, for instance, through the Fashion Pact, but also beyond our industry, and for instance, especially with the food and the meat industry when it comes to leather. Indeed, it's also with this collaboration that we will achieve impact, and especially when it comes to traceability. And finally, something which is very important is also engagement. So beyond just the supply chain actors, but basically towards external stakeholders, such as consumers, in order to raise awareness on what actually is sustainable leather, but also to get in regards to academia, for instance, in order to get actually this scientific evidence that backs up sustainable leather as an alternative. And so now I will jump straight into how we actually measure our impact by presenting you the environmental profit and loss by Kering. So at Kering, we've been deeply committed for years to understanding what is natural capital and how we depend on it, and what we can do to protect it. So this is why around 10 years ago, Kering developed the first environmental profit and loss tool that provides the backbone for us to measure our environmental impact, to understand this impact, and then act according to the conclusions of the environmental profit and loss. So the way the environmental profit and loss works is taking a very innovative approach for capturing environmental impacts, as the methodology includes life cycle assessment for all the different materials that we use, but then take a natural capital approach by looking at the cost of this impact to societies. So if I take, for instance, the example of land use, which is one of the 6 key areas that the EPNL look at, we will start by looking at, okay, what's the area of land that is needed to produce a commodity, and what type of ecosystem is in this area. Then I will measure what's the impact of my activity on this land, and then basically I will translate that into impact in terms of health, in terms of economic losses, in terms of changes in natural environments, and convert that into monetary value. The importance of converting the impact into monetary value is that it enables us to basically compare these 6 different categories of impact between each other, because otherwise comparing greenhouse gas emissions, for instance, with water consumptions would be impossible, because you would be comparing bananas with apples, for instance. So being able to translate that in economic value actually gives you the ability to prioritize and to compare these different impacts that would be otherwise impossible. When it comes to the results, we know that thanks to the EPNL tool, our largest environmental impact actually occurs at raw material production. And specifically, they are mostly around land use change, which is directly connected to biodiversity, and to greenhouse gas emissions. So taking together, the message is very clear. In order to have a real impact, we need to focus on tier 4, so it means all the way down to raw material production, and prioritize nature-based solutions that offer dual benefits on biodiversity protection and carbon emissions. And so this is why, with this knowledge, we've implemented in the last years a lot of different programs at that level in order to reduce our impact. And this has shown results. Indeed, our initial objective is to reduce our EPNL by 40% by 2025. And we've already achieved 29 in 2020. So we are right on the path to reach our objectives. Another thing, it's important to know that we update this tool constantly. Every year, we do updates to the methodology to reflect best available science and data, and we share these results publicly. Also important to note that all of the methodology of the EPNL is actually open source, because we really want to promote natural accounting beyond our own borders. When it comes to focus on raw materials, so you will notice, so at the bottom part of the graph, that leather is by far the first material sourced in Kering. It's very strongly associated to our houses that use it mostly for leather goods and then also for shoes. But it's also the materials that has the biggest environmental footprint as measured by the EPNL, ahead of fibers, natural animal fibers and metal. Also, the same way that the overall impact is mostly due to greenhouse gases and land use, we also see the same for leather, so same profile of impact. Now I will dig deeper and show you a very short live demo of our tool. So this is the ePNL open source platform that you can access by Googling ePNL and carrying. And what it enables me to do, for instance, if I want to know on leather, how does my impact look? I check, for instance, calf leather, and then immediately on the map, it will highlight probably the countries that have the biggest impact. I can also, since I know that most of the impact is happening at the farm level, I can filter so to only have a look at this impact. And then I will show, for instance, that probably France, Holland, Italy, and the US are the countries where I have the biggest impact, and I should prioritize action. I can also have a vision of this in terms of graphs, which enables me to have a closer look maybe at comparing countries. And so, for instance, if I do the same, looking at France, looking at Netherlands or the US, I will be able to compare the impact of these countries when it comes to animal rearing, for instance. So here I see that while for France and Netherlands, the impacts are pretty similar. If I source the hides from farm coming from these countries, in the US, the impact will be much bigger due to the practices of farming, or due to maybe the ecosystems in which this farming is happening. And so the message would be, okay, maybe I should focus on trying to reduce my impact in the US. Maybe I should redistribute the way I source to focus more on European sourcing. So that's just to give you a snapshot. This tool is very comprehensive, so don't hesitate to go there and dig deeper. So now that we've seen where is our impact, it's important to recognize that it's important to address the impact of leather. Indeed, the production of leather at the farm level can potentially have negative impact at this farm level. So both on the environment, on the social aspect, and then on animal welfare. These impacts can be direct impacts, such as conversions of natural habitat to pasture or impact on animal welfare. They can also be indirect, such as feedstock from unsustainable sources, for instance. But they can all be turned around, and you can always implement actions in order to actually have sustainable sourcing when it comes to leather. That being said, the only way that carrying can truly mitigate its risks associated to leather sourcing is making sure that we have transparency and traceability. So we know that traceability is a challenge, but really we don't have any choice now. We really need to engage with our leather suppliers to work towards more traceability, to be able to have full visibility down to slaughterhouses and possibly to farms in order to implement and drive change. What do we do at Caring to tackle the challenge and to turn leather into a sustainable raw material? So I would say that the backbone of our ambition and the way we work is really on our carrying standards for raw materials. So they basically provide a way of measuring progress and outcomes on traceability, social welfare, environmental protection, animal welfare, and chemical use by giving clear guidelines to our brands and to other suppliers on how they should source. Second very important pillar is our animal welfare standards that also gives examples of, for instance, which kind of certifications you should try to identify in your supply chain in order to really ensure that animal welfare is respected in the supply chain. They give very detailed by species recommendations of what should be the practice in the supply chain. Another very important pillar is also what we call resource efficiency by, for instance, minimizing offcuts, putting offcuts to better use for upcycling. So I can name an example of, for instance, Gucci's scrapless methodology that enables them to significantly reduce the waste that they generate while in the tanning operations by simply trimming the hides to size before tanning. And finally, and that's the last point I will focus on, is also by scaling up regenerative agriculture practices within our supply chain, because as we've seen, most of the impact is happening at the farm level and is really on land use and greenhouse gas emissions. We really believe that implementing such practices is key to solve the issue of sustainable leather sourcing. What do we call and what do we mean by regenerative agriculture in caring? So we basically see it as practices that deliver outcomes and that are significantly positive for the environment, for the people, and for animals, with 5 key pillars. The first being on soil health and soil carbon. The second one being on biodiversity preservation and biodiversity restoration. The third one on elimination of unnecessary synthetic and harmful chemicals. The fourth pillar on improving farmer livelihood. And the final one on making sure that animal welfare is respected and enhanced in our operations. We do recognize, though, that implementing regenerative agriculture is a very difficult journey, and it's very difficult to scale up. It needs additional resources and sometimes investment, financial investment. So this is actually why this year we at Caring have launched the Regenerative Fund for Nature, that has as a goal to help the transition of 1 million hectares of existing farms into regenerative agricultural practices. The call of proposal actually just closed off. We've received quite a lot of applications and we're really looking forward to review them. They are focusing on 4 key commodities for caring, leather being one of them, but also looking at wool, cotton, and cashmere. And so we're really eager to kickstart working with the grantees that will be selected from the applicants in order to help them to transition to better farming practices, kickstarting the fund with the grantee over the summer. So that was all from my side, and now I'm looking forward to receiving your comments and your questions. Thank you very much for your attention.
Thank you so much, Johan, for this overview and specifically for the insights into the environmental profit and loss account, which is certainly very impressive, a very impressive tool, and the positive impact this has had. So yeah, thank you, Johan.
Thank you.
You can post a question to any of the presenters using the GoToWebinar control panel on your screen. Questions that we haven't covered today will be forwarded to our speakers so they can respond. Please make sure you specify the name of the presenter your question is addressed to. So, Michael and Sasha, so I would like to follow up your presentation with a few questions, if that's okay. Michael, I'll start with you maybe. You studied a number of different materials. For example, let's take one of them, Deserto, which is known as cactus leather, and which, to my understanding, is virtually 50% composed of plastic materials derived from fossil fuels. Can you confirm whether this is correct? And do you feel that their product claims and other non-leather materials in this study often mislead consumers into what each material is composed of?
You know, this is a delicate question. If I'm right, Deserto is described as a vegan material. I've looked on the website, which is partly degradable and PVC free. These parameters are correct, of course. It is based on polyurethane. It is partly degradable because we find organic components or organic fillers inside, and it's a vegan material. We cannot measure this, whether this is vegan. So the description is correct, I think. In regard to the sustainability, we cannot measure it. In this case, a correct LCA, life cycle assessment, would have to be done, but this is not part of this study we did. Regarding the sustainability and the biogenic source of the raw material, of course, we have components of organic material. This can be from cactus, of course, but the other components are polyester, and on one hand, and on the second hand, polyurethane. So these are fossil-based, and this has the sustainability is as it is for fossil-based materials, I think.
Okay, great. Thank you for explaining that. And if we compare specifically the physical and haptic properties of all the materials as a whole, how would you say does leather compare against the other materials you tested? How do you think each material would last over a longer period of time?
We tested the physical and the haptic properties, right? regarding the haptic properties, just as an example. Sasha was talking about the universal properties of leather. And as you can imagine, an upholstery material or an upholstery clothing, leather for clothes, for example, is completely different to a leather made for soles of shoes, of course. So the range of properties is very broad in case of leather. So what is the correct description for this, to compare this? So we tested it, and it is impressive that leather can be made in this broad range. This is not possible with the synthetic materials. Usually then you select a couple of unique properties which shall be copied, and then you develop a material which appears, for example, for like a leather which is made for upholstery, or a leather which is made for clothes, for example. So I would say it's a difficult question, because we would have to define what is leather exactly.
Yeah, that makes sense. That's a fair point. Thank you. And it was interesting to note in the study that the animal rights activist group PETA had named one of the leather alternatives on its approved material list, yet it contained leather fibers. Does this illustrate that there is a lot of still misinformation and inaccurate reporting in the media or social media around these materials?
Yes, I think there is very much misleading information, of course, but this is, I think, also a part of marketing. You have to sell a material, and you try to advise the best for this. Regarding the results we found, I don't know how much steps the material had, or for the construction of the material had been done before the material exactly came in the market. For example, it was composed of 5 different components, completely different materials, which had been combined by sewing, I think. And in this case, it would be necessary to completely trace the materials, and to make something like a traceability study, and to be transparent, I think. And this is, I think, the most important thing, not to spell or to advise wrong things, to be transparent, and to just advise the right and the correct things. And then I think it would not be misleading, and in the end the customer has to decide what he wants to have.
Yes, absolutely, that's right. And finally, you also mentioned that some restricted substances were found in some of the samples. Which materials were these, and should there be any concerns for anyone using these materials?
So we looked for restricted substances by applying a screening method. The screening method we performed here on our institute was based on a thermal desorption analysis. So this means that we looked for volatile compounds coming out of the materials when they are applied to heat. And we could find some restricted substances like residues of solvents, but also some non-reacted adducts, for instance. And we could find some restricted substances in the coated textiles, and also in some of the fiberboard materials. However, of course, restricted substances are always substances of concern. This is not the question. The question is how we can optimize the manufacturing of these materials in order to reduce these restricted substances, or even to exclude this application of restricted substances for manufacturing.
Okay, thank you. Thank you for going into a little bit more detail on all these points for us. Thank you. And yeah, Sasha and Michael, once again, thank you so much for taking the time to do this webinar for us today. Thank you.
You're welcome.
So Kim, I've got a few questions for you also. Firstly, do you feel that an LCA is a reliable tool both for the supplier as well as brands to assess the environmental impact of leather, or are there any shortcomings? And what other areas of product development can a comprehensive LCA inform?
Well, Isabella, the LCA as a framework is under development, right? It's not. It's a work in progress, and it's being they've been working on it to make it comparable, because it's a very important aspect of it, right? So being able to compare between different materials, and supply chains and production systems are very different. So it's a very big challenge to be able to do that. But it is, I mean, it is reliable, and it's at least the most reliable tool we have so far. But I'm sure it will get a lot better in the years to come, because people are actually giving it way more attention. Universities are giving it way more attention, so it should get better and better and more precise and more comparable. And that's an important point, right? You have to choose between precision and comparability, and they've been working on how to get the best choice there. And what other areas can a comprehensive LCA inform? Well, the thing is, it should work for all production systems, all areas, even services. So it's supposed to work for everything.
Okay. And how much does the kind leather concept reduce waste compared to conventional leather? I mean, how much can be saved in water, chemicals, energy, transport, and waste treatment in terms of costs and volumes, and just generally the environmental impacts?
So what we did to compare kind leather and the regular leather was we ran actually 2 LCAs. So the old approach, where we didn't have any optimization regarding chemical usage or material usage, with the kind leather approach after all the developments. And the numbers we achieved here, and again, it's very specific for this article we assessed, the numbers were roughly 43% less global warming potential from cradle to gate. And when we talk about waste generation, the number is actually astonishing, because it's 93% less. And it is so because you actually don't trim the leather after tanned. You don't trim the leather along the process. Well, sometimes very little, but mostly nothing at all. And that's it. I mean, it's a lot less waste along the process, and multiple other impact categories, and they are all available in our website. So if anyone wants to check the different impacts and the differences.
That's good to know. And yeah, as you say, some quite considerable efficiencies there. And some companies may be shying away from conducting LCAs, either due to the cost factor or the process itself, or because they maybe fear a negative outcome that might expose some vulnerabilities or shortcomings there. What would you say to that?
Well, the cost factor is, of course, something that should be considered, but I mean, companies should ask the different companies that provide the service, because it might be prohibitive to some, but it shouldn't be for most of them. But about the negative outcome and how their results and what their results might be, well, this shouldn't be a worry at all, because the thing is, the LCA is for you, right? It's for the company, so you can use it the way you want to. You don't have to disclose the result. You can use the results only for yourself, for a first picture, and then to improve. And then during your next LCA, even if it's a few years from now, after all the improvements, you'll definitely get better. So if you don't do it, you won't have a way to measure it, right? So this shouldn't at all be something to push you away from it. The information is yours.
Yeah, that's absolutely true. That's good words of advice there, really. And as you said, so it's a useful tool really for any company to identify any areas that might need improving or could be improved. And finally, has the process of devising an LCA for kind leather led to process changes and procedures at JBS Kurus to reduce your own carbon footprint?
Well, yeah, definitely. I mean, there were a few that were very easy and very simple to change. But we didn't change a lot so far. What we are doing is we are studying the variables and we are testing. So we didn't change at a production level a lot of things, but we are planning on doing so. So, I mean, we've learned So regarding chemicals specifically, in about loading of drums, for instance, a lot of variables that make all the difference in how your leather is assessed, and we are actually working on improving also. Again, the chemical part is something I'd like to highlight, because one thing is the chemical itself, and the other is what impact is attributed to that chemical, and those are two different things. Because as soon as you have a proper assessment of that chemical, and that's what we're working on with our suppliers, you can actually get a way more precise number. So that's also something we are working on with our sourcing teams.
Excellent, brilliant. Thank you very much for that, Kim.
Thank you, Isabella.
Johan, we have a few questions for you too. So you said that to achieve greater results in terms of reducing the environmental impact of your raw materials, especially leather, it's important to engage and work closer with suppliers further down the supply chain, such as the food and meat industry and slaughterhouses. And how far can you positively influence their practices and methods, considering that leather is only a byproduct?
It's a great question. It's definitely a challenge. I'm not gonna lie. As you say, the fashion industry is I would say dependent of a co-product from the food industry. So we usually don't have the full leverage. That being said, the fashion industry is very visible and much more vocal on this topic than usually the food and meat industry. So I believe it's more from that angle that we can actually take the topic. And actually, by collaborating with the food industry, usually the food industry is also willing to and quite aligned on the ultimate goal of driving sustainability. Is just to kind of create this ground for common understanding, and then also potentially actually go as not just one brand, but more like coalitions, which is also very important. So, for instance, there are many coalitions. Group of companies working on that. I mentioned the fashion pact, but you have, for instance, also textile exchange with the responsible leather impact accelerator. All of these coalitions and group kind of gives also volumes for the brands to come, maybe not alone, but with other allies and other companies. So I think that would be the two things I would say. So I agree that it's maybe more difficult than in other, for instance, like cotton, where we are the direct users, but still, I think results can be achieved.
Yeah, excellent. Sounds like it's due to the sheer size of the collaborations as well, but also maybe a little bit of reputational pressure that can help there as well. And you said in your presentation that obviously transparency is extremely important. What checks and balances do you have to ensure your supply chains are fully traceable and transparent?
So we work in different ways when it comes to traceability and transparency, which for me are two complementary things. Transparency is really getting this visibility into the supply chain. And so, for instance, the way we work today with the EPML in order to actually be able to map our supply chain all the way down to the farms is mostly through suppliers' declaration. So they declare the sourcing countries of farm, of slaughterhouse, for instance, and then we might do spot on checks to actually try to verify that. And then when it comes to traceability solutions, that's more what I see like the technology solutions. So we are piloting a different set of technologies in order to be able to trace physically the materials. So we have pilots, for instance, with laser marking, both in France, in Italy, in South Africa. And we are also piloting other types of technology in order to gain the traceability, not only the physical traceability, but also the software platforms that are necessary. As I say, it's a challenge, it's a lot of investment, and actually, I think one should not underestimate the fact that it's the technology, of course, can be a barrier, but it's also the collaboration. I mean, you also need to really engage and explain to your tanneries why you want to do that, and then your tanneries need to talk to your slaughterhouse on why you need to do that. So I think there is both, like I would say, like a hard solutions, which is like the laser or the technical solutions, but there is also all of these soft solutions that you need to develop in parallel.
Yeah, that's very interesting. And since Kering began its EPNL, has the environmental impact of the leather you source and use in your end products reduced? What are the next steps to reduce its impact further?
Absolutely. So as I was saying in my presentation, so we've reduced our overall environmental footprint by 29% as measured by the EPNL, and that includes leather. Leather being the biggest. I don't have the exact number for leather. I believe you can actually find that our online platform, but it would be basically on the same kind of range, because basically leather drives all of our overall impact. And the way we've achieved that is mostly by either changing sometimes our sourcing practices, so changing countries, maybe eliminating high-risk countries or countries that have higher environmental impact, but not only, because we do believe that it's also important to actually drive change. So staying in countries where maybe you have higher impact. So I showed, for instance, in my live demo that the US or Australia, for instance, are countries where we identified that the environmental impact is higher, and there it's typically where we are going to try to implement projects to maybe source from farms that are more regenerative, or help the farmers that we currently source from to transition to regenerative farming. And that's also why we really now are happy to have launched the fund, because that will basically help us to reach maybe the last 11% we need in order to fully achieve our 2025 ambition.
Great. So with all of this in mind, what you just said, would you say that Kering as a group is still committed to leather as a material and will remain so in the future? And do you feel that leather is or can be a sustainable product?
So I'm not a creative designer, creative director of one of our houses, so I can't speak for them. But I mean, it's obvious. I mean, I would be really surprised if leather would disappear from Kering houses. As I was saying in my intro, it's really strongly associated to our houses. It's a material that our customer love, our designers love, and so we have no reasons to go away from it, because we do, and that answers your second question, because we do believe that it can be basically produced and sourced in a sustainable way. I think. But it's important that the leather industry, the fashion industry, really realizes that it's possible, it can be done through implementing traceability, implementing resource efficient methods in your supply chain, regenerative agriculture. And so in the end, I think leather has a very strong potential, as any nature-based materials, to really position itself as sustainable. If all of the conditions around environmental, social, and animal welfare impacts are met, I have no doubts about that. I know that, I mean, you will always have consumers that have specific consideration when it comes to animal-based product, and that's a personal choice. But we do believe that leather is a sustainable option that should be and that should stay in the future for Kering.
Yeah, that's great. That's not only good news for the leather industry, but also a really great message to leave this webinar on, you know, that there's still work to be done, but it is happening. And, you know, with more collaboration in the industry working together, the improvements can and will be made going forward as well. So thank you very much, Johan. That's been a pleasure having you. And yeah, thank you for the insights you've shared with us.
You're welcome. Thank you, and have a great day.
So this concludes our webinar for today. A big thank you once again to our presenters for sharing their data, research and expertise. I would also like to thank JBS Kuros once again for the sponsorship. We will be posting the full webinar online shortly in case you would like to listen to it again. A link to the recording will be also sent out to everyone who registered for today's presentations. Finally, you will now be asked a short survey about today's webinar, which will give us valuable feedback to ensure we're offering content that continues to be of interest to you. As mentioned at the beginning, ILM and the SAWA report will be hosting more free-to-attend webinars, as well as new podcasts over the coming weeks and months, so please keep an eye out for future topics on the ILM website. Our contact details can be seen on the screen in front of you now. Thank you for listening, and goodbye.